Hi there, welcome to lesson 2 of this ATMega328P basics tutorial. So in the last lesson we put together the schematic for this basic board, and in this one we're going to start the PCB. So the first step is to open up the schematic we worked on in the last lesson, and then up here click the board button. Now it'll come up saying the board does not exist, would you like to create one from the schematic? Yes, we do. So I click yes to that. So what this has done is given us a blank board and it's just dumped all of our components in the corner. So we want to move all of these onto the board. So I'll select the move tool and then select the group tool. And that allows you to drag a box over all the components, highlights them, but if you go to move them, it'll only move one. So you want to use this group tool to select them all and then do right click, move group. That'll pick them all up. You can pop them down here. Component placement is an important part of the board design. You want to try and get your components in the best places before you start routing. Otherwise, if you've got things too close together, it's going to be hard to get tracks between them. If you've got things overlapping, you're just going to have to move things about and shuffle them until it works. It can be frustrating, but a bit of patience, it does pay off. So we're going to rotate this round, and we really want the crystal as close to the chip as possible. I'm going to put it about there. Move our capacitors down and put them, rotate them around and put them in line with the ends of the crystal. Now if we press the rat's nest button, you'll see it's moved some of these yellow air wires. These are just indicators that show where you want to make your connections, and you can check where check where those connections want to go. I've actually got this side of the resistor should be connected to this side of the crystal. You can see that air wire going straight through the middle there. You can just confirm that by using show and clicking the air wire, and it will highlight all the pins on the same net that you want to be connected. So we'll just spin that round. Use the show tool just to demonstrate that. Okay. So we're going to do our first route now quickly. So don't use this wire tool. We want to use route to lay down a track. I'm just going to set the track width. Oh, we're in inches again. Come on. So I've just clicked the grid tool and select millimeters again. Yeah, that's all fine. I'm going to select finest again there. And I'll select thought, hack Varna. I think the minimum track size is 0.254 millimeters. So I'm going to go for this one up. It's a fairly reasonable size track for this. And use right click again, cycle through and select a nice diagonal clean track going out to that. Do the same again for this one. Make these connections here. Okay, that's our crystal connected up. And then want to add this resistor going from our reset pin. So exactly the same, use the root tool from the chip pin to the resistor and click. Every time you click this this rat's nest tool, sorry, you'll see you've got 12 air wires remaining to route. So we will move our power pin around here. And some bits for our end there. Let's just go down there. Now sometimes you'll find when you go to place a component you can't quite get that air wire straight, so when I set that grid spacing to finest for alternate, if you hold down your Alt key, you should be able to move it freely and press it exactly where you want. Just do that for both of these. Okay, I'm just going to move those in a bit. Using the group tool again. We'll group that quickly. Into the LED, back out the resistor. The other end of that will go to ground. So power header on there. Okay, the next step we want to do is just hook up the power to the chip. So I'll use the C command, and we can see, okay, these need to all be connected here. Yep, we can do that. So we'll take a track down here. Other pin of the chip, and the same again from this one up onto there. So that's that all hooked up. Oops. I'm just going to give some power to this other side of this resistor. What I'll do is just make that a little bit easier for myself by spinning it round. And if we hit the rat's nest again, I'm just going to get that over there. There we go. Okay, so we want to connect power to here as well. Use a quick meter. No, I think I prefer this one. Down there like that. So back to that, we'll just hit rat's nest again. We've got 6 air wires left to connect, and most of them look like grounds. I think they are all grounds. Yes, they are. So what we're going to do for that is we're going to add a ground plane on the back of the board. We'll do that by selecting the polygon tool, starting in the bottom left hand corner. Make sure we're using the bottom layer. This might have had the top layer selected at first, but we're on the bottom layer at the moment. Take that over to this corner here and click, and down again. And click there to close it. Right, so if we press the rat's nest button, there we go, that's filled that all in behind our components. What we want to do is make sure that is connected to ground by renaming it, clicking the outside and selecting GND. There we go, we can see that's connected to ground because it's added these thermals in, connecting to our ground pin where the header is. So we're going to add some vias. Vias basically connect between the layers of the PCB. So we're going to use the via tool, select round, select the drill size as 0.3 for hack vias, making them. And we'll do the same again with a layer. We'll rename this to ground. So that will make sure that is connected to the ground layer underneath, and then we can simply route to that via, and it's going through the via to the other side of the board, which is grounded and connected here. I'll just check that that is, yeah, that is 0.3. I'll use the copy tool, so whoops, in the middle of it, there we go. Just add another one down here. Same again, pop one down here. I'm just using the Alt key to place it centered along that pin. And one more. Oh, and another one here. I could just connect that up there actually. Yes, I'm going to do that. Press the escape key to get rid of that. Oh, these aren't very well lined up. Just use the move tool to. I think that's better. So we can route straight from that pin to the vise. There. I think we're all done. Press the rat's nest one more time. Nothing to do, so that's all the air wires done. So this board should now work. The only thing it's missing is a programming header to actually be able to get some code onto it. Because if we soldered this on, it's not going to have any code there. We're going to power it, but nothing's going to happen because there's no code. So now what we're going to do is add the ICSP header, and we're going to use for programming. So if you just Google the SparkFun in your library, you should be able to download this. I'd download all of these and just stick them in your libraries folder like we did on the first video. Loads of useful stuff to have in here. So if you copy the whole folder in instead of the libraries individually, they'll just be put into a subfolder like this, and you might have to go through and enable all of those again. There we go. Now's probably a good time to demonstrate actually. If you do accidentally close one of these, you'll get this FB annotation has been served. And what that basically means is if I go ahead and start changing things on this board, it won't update the schematic. Usually if I change things on this or change things on the schematic, it'll annotate them either way. And yeah, so this is a problem if you get this. So I usually just close it and open it again, and then you get both back, and they're both linked. Any changes you do will be carried back and forth. The last thing you want to do is get both of them out of sync, because it's a right pain to get them back in sync again. So right, to the board file, as we were, and we'll go to the add menu. We'll pick up our SparkFun connectors library, and the one we are looking for is no, not any of those. AVR SPI. Okay, we want this one here. You can see this one, two of the pins are slightly offset to lock it in. I don't use that one, I just use this standard one. You can just use two 3-way strips of header for it. So we'll insert one of those. AVR SPI PRG 6 PTH. Okay. I'll just pop this over here. And press escape out of that, and escape out of that. So this is the header we're going to use to program the chip. I'm just going to make a few connections onto the chip. So I'm just going to start off by popping some wires on here. There's one longer. And back up we'll add another one of these labels. Come on, why has my grid changed again? Millimeters. Oops. 1.27 minus. Sorry, I've had to start the video again another day. We got halfway through it and I had to change all the settings. So yes, we've got this label here. Size to 0.8-ish, 0.8128. And we'll put one on there. And just go through all of the pins. Do that. And then we'll use the name tool. Set these up. Oops. I'm going to give them the same names as here. MISO, SCK, reset, ground. Yes, we do want to connect this to ground. MOSI. And for the 5 volts, it doesn't actually have to be 5 volts, it's just the programming voltage of the chip, which we're going to connect to VCC. So what we need to do now is make the same connections going from here into the chip. So we'll start off with the MISO, and that goes into PB4. Name that MISO. Would we like to connect them? Yes, we would. And we'll just go around and do that for all of these. So the next pin is MOSI. That goes into PB3. Now the SCK line, that's actually connected to PB5, which is the same pin as our LED. It's no big problem. We'll just basically, I'll take another line off there. Junction there so we know it's connected. Pop a label on it. And we'll rename this to SCK. Yes, we would like to. Okay, so they are all connected. The other thing we need to connect is just the reset line. And what we do, we put this 10k pull-up resistor here. The reset basically comes off of this. Put that one higher up. The junction on and another label. And then we can rename that to our reset. So that's all the connections complete for that. I'll save it and switch back to the board. So you can see it's just popped it down here in the corner. Just move that into the empty space there. There's quite a lot of these labels that get in the way, especially the one for the crystal. So what we'll do is we'll just right click the crystal and choose smash. And what that's done is taken these labels and separated them, ungrouped them from the crystal. So we can then use the delete tool to just get rid of the labels. Now it's really worth smashing all of these, and then I'll get rid of the values and just keep the component names, because then you can come back to your schematic and check all the values when you are assembling the board. I'll smash a few of these off. Just move the values along. So again here, smash. I'm going to go ahead and call this the ICSP header. Just center that across that. Right, so what you ideally want to do is try and line this up in a way that will make it nice and easy for you to route. So I'll probably spin this around a few times until it looks a little easier. I think it's actually going to be easiest like this. Yeah, it's not too obstructive. We'll see how it goes. Okay, I'm just going to move it over here and centralise it a little bit. Okay, so we'll use the root tool. Select the 0.3-ish millimeter track. Going to use the top layer and just basically that's what I wanted. Split off of there, come down into there. Now for this one, we're actually going to use the bottom layer, so I've clicked the middle mouse button, that's taken us over to the bottom layer. Click there, nice and straight, take it up. Click again, press the middle mouse button one more time, and then into the pad. Now you see that you've got these settings up here. Really, you want that via selected as round, and set the drill size to 0.3 millimeters again for hack varner. And I'll just change this via here by going to properties. You can change it to 0.3 and round. Apply and OK. Just do a few more of these. That should be okay. We could use a thinner track here if that clearance is a problem, but we'll check that later with the DRC and see what it says. So for the rat's nest, that again, there we go, we've automatically, using the rat's nest, connected our ground there, because this ICSP header is green, so that means it's on both sides of the board, it's connected to both sides of the board. And the very last thing we need is power. Take that. I'll just run it straight around from over here. I'm going to start over here. There. There we go, nothing to do. So now in theory you should be able to make this, program it, and you should be able to get the LED flashing. Obviously it's a bit of a useless circuit, just flashing the LED, but this is our basics for our ATMega. I'll just smash a couple more of these off now actually, just to make it look tidy. Some of these, smash, smash. Ah, maybe I'll really smash that one. Yes, alright. Whoops. I'll keep that. LED1, we want that, yes. I'll smash this here. Okay, as far as our silk screen goes, what we can do is add some text. I'll click on this text tool here. Click on this test board. Okay. And we want to change the layer to T-place sublayer. I'll just find somewhere to stick that. Oh, there's not a lot of space. There we go. And press escape. Let's get out of that again. If we right click this text we've just put down, change the font to vector, we definitely want that as vector, and apply that. And change the size down a bit. I'm not entirely sure of the maximum and minimum sizes for text with hack varner. There are some limits, but you'll have to look that up. I'll probably come into that in a later video. But yeah, you definitely want them as vector. So I'll just change all of them to that. I think 1.27 millimeters is a safe size for those. and we'll save that. Okay, just check the rat's nest one more time. Yep, still got nothing to do. So what I really want to do now is, if we get up the HAB website, and we look up about the, scroll down to the PCB section, we want this guide for HAB PCBs. Now everything you possibly want to know about ordering from him is in here. There's instructions for everything. We want to search for the DIU file. There we go. We'll download this. It's just in Hackvarner's GitHub. Download that and save it wherever you fancy. Because what we're going to do is close this. We're going to click this button here, which opens up the design rule check. Press the load button and browse to your Hackvarner DIU file you just downloaded. I keep it in the DIU folder of Eagle for easy access. Just apply that and then press the check button. So there we go, we've only got one error. That's a good start. If we double click that, there we go, we've got a drill distance error. What's the problem there then? I'm not sure. Maybe we've got two wires on top of each other. We'll find out. I'll just try moving it. Yes, we did. That was the problem, right. We'll delete the one on the bottom. Oh, sorry, because this is a wire, we have to use this rip up tool here. So we use this for removing traces and wires. Get rid of that and move that one back over the top. We'll run the DRC one more time. Check. There we go, no errors. Fantastic. So we'll save that one last time. So thanks for watching. If you've got any questions, leave them in the comments or ask me. Hopefully my next video will be connecting the NTX2 to a Arduino board just like this. What we'll probably do is use this as a base board, and in future tutorials we'll take this as a starting point and expand on it and add things to it. So stay tuned for the next video. I'll try and get another one done in the next couple of days. I think we'll go for connecting the NTX2 up to this ATMega for the next video. It's quite straightforward, just a few RF design things to consider. Thanks for watching.